Welcome back. Last time we explored interfaces in TypeScript and saw how they help enforce consistency in our code. Today we will level up by diving into generics. Generics are one of the most powerful features of TypeScript, allowing us to write flexible, reusable, and type-safe code. Generics are a way to create components or functions that work with different types while maintaining type safety. Think of them as placeholders for types, similar to variables but for data types. Imagine you're building a box that can store different items, books, clothes, or even tools. You want this box to work with any item type, while ensuring you don't accidentally mix them up. Generics give us this flexibility in programming. So I've created a simple generic function to better understand how it works, and here's an example. In this example, T, or what we see here, T is the generic type parameter. It allows the identity function to accept any type and ensure the return value is of the same type of T. This makes the function flexible and type safe. So let's say we put string here and the string goes in and here's a string, right? It will give an error, but that's basically what you're doing if you put a string in here. If you put a number in here, all of these will be replaced by a number. T is just a placeholder for whatever type we are going to put in here. As you can see here, let's run the code, and there you see it. We return the value, right? Identity, we return the value, and here we put in a number, and it's all fine because we are using generics. Number is fine, string is fine, it's all good. It's not the same as any. It's not the same as any because any allows you to put in anything, and you won't know what it is. Here, we know that if we put in T, a number, it always returns a number. That's why it's type safe. So what we also can do, they're very useful when working with arrays. So I've created a function that accepts an array and returns the first element. So here I put in T, so array of type T. See, array of type T, it returns T or undefined. And what it does here, we put in numbers and we put in strings and it will output 10 and this will output apple. Now let's compile it again and let's run it again. See, first of all, it prints, of course, all of this code, and then we go up to this code, and then 10 is the first, it's at the 0 index here. And then it prints apple because that's at the 0 index here. Now, when we put in an array of type T here, so we put in an array of type numbers, right? TypeScript infers that this is an array of type number because we only put numbers in here, right? Same goes for this one. It sees that this is a array of type string because we put strings in there. So it infers that, and that inference is used when we put it in here to see that this is a type of number or an array of type number. And this is an array of type string because it only holds strings. Now, T here is used, so we know it's either number or string, depending on which one of these two we put in. So it will say number here, and it will say number here, and it will say number here, or undefined. And that's what it does. It runs the code, and it returns array 0, so 10, and 10 is a number, so here it returns number. And that's how it works. Generics can also be used in interfaces and classes to create reusable data structures. Here's a couple of examples. I'm using generics in classes and interfaces to create flexible and reusable components. Here I'm using, let's comment this one out real quick. We have created a box that can be of type anything, right? Type string, type number, whatever you want the contents to be. And you see that it is this interface. And interface has a property called contents, and the contents is of type T. So in this case, we have defined the T to be string, and here we have defined the T to be number. So here we always know that it's type safe because we have specified it here. Now, when we console log this, here we console log contents, and here we console log contents, see that it already knows that this is a number. And here it already knows that it's a string because this is a string box and this is a number box because we defined it here before. And now it's flexible because we can reuse this interface for whatever type that we need to use. So let's uncomment the rest. Now I've created a class store of type T. You see, it does all of this. All of this stuff works with type T. So let's go through a code example here. We have number storage, right? And I've made this class with type number. So it uses a generic, and in the generic, I have put type number. And number storage has a function or method called addItem, which accepts an item of type T. So it can accept an item of type number in this case, because we have defined it to be a store of number. Now here we put in the 1, and here we put in the 2, and it all goes fine because basically it says here number, number, and number. And that's all good because we have done that. We have done that. We have done this with number everywhere because we have done this. We're all using this syntax. It knows that everything should be of type number. So that's what we've done. And now here we have a string storage, and we've done the exact same thing, but we're using strings right now. So we've used two strings, we added them, and now we have a separate number storage and a separate string storage. And now we're going to print all of the items. So let's run this. This is interfaces, so it's all good. I have to save it, run it again, and I'm going to comment this one out, save it again. See? Now here, it all works well because we have defined the generic to be number. And here we have defined the generic to be string. And that's what you get. So you get a number array here and a string array here. And that is how you can reuse or make your code more generic. That's where the name comes from. You can make a generic store class to store stuff. And this could also be another object. Or we could also, you know, put in any other class that we make. Maybe we make an animal class and we say this store only holds animals. So anything that adheres to a animal interface will be stored. And this will be like an array of animal interfaces. And it all works. It all works because of generics. Now, we can also add constraints to generics. Sometimes you want to limit the types that can be passed to a generic. TypeScript lets you add constraints using the extends keyword. So here, the print length function only works with types that have a length property, such as strings or arrays. If you try to pass a number, TypeScript will throw an error. Let me quickly rewrite this into some nicer syntax. So here we have said that the print length function only works with type that have a length property. So we have said T, so our type T extends any interface that has a type that has a length property. And then we pass in the value and then we say void, because otherwise we cannot be sure to call the length property here, right? Because if it's something else that doesn't have the length property there, our code will explode and we will have a bad day, and we will have the PO calling, and we will have the business calling because there's bugs everywhere and people are losing money. So we don't want that. So we have said here that our type, whatever type we're going to use, needs to have a length property. So here we have a string, and the string has a length property, as I can show you here. See, length property. Same goes for an array. An array also has a length property. Now, if we try to put in a number, we'll get an error because a number doesn't have a length property. If we go here, it has no length property. See, it doesn't have a length property. It tries to fill it in because it's Visual Studio Code, but it says ABC here, right? That means that we don't have anything, because here it's like a cube or a block or a Lego block, whatever. It says property, and here it says ABC, and it doesn't say anything behind it, so it's not there. That's how you know that this one doesn't adhere to the extends. So that's how that works. So you can constrain all the types that go in, and they at least need to have a length property for your code to work in this function. You can also provide default types for generic parameters, making your functions or classes even more versatile. In this example, the default types for t and u are string and number, but you can still override them when calling the function. So here we have create pair t equals string. So whenever we don't specify what it should be, it's a string and it's a number. But here we have put in a number and a boolean, because true is a boolean and 10 is a number, right? So you can define default properties because it's sometimes handy to do that. And then you can also override them whenever you need to, but it's the default params that you will use. And then it returns first and second. Now let's run this code real quick. Bam, there you go. So here it puts out 6 and 3. That's the previous code. And here it puts out the array, Alice 42 and 10 true. And that's how you can use default parameters or default types for your generics. Now we're going to the exercise. I want you to create a queue class using generics. The queue should have methods to enqueue items, dequeue items, and check if the queue is empty. Pause here, try it out, and then we'll review the solution. All right, so I've created a queue class with a generic here of type T. We have an enqueue item, dequeue, and isEmpty check, and they all use this, right? So what are we doing? We are creating a new queue of type number because we have filled in the generic here to be of type number. So we can enqueue 1, enqueue 2, dequeue, so it shifts it and it outputs 1, and then we can check is empty. So let's run this. I wanted to say that, but let's run this. Answers.js and answers.ts. So we run it and it says 1 here and false here, just like I said in the comments, right? The queue can work with any type and it ensures the flexibility while keeping the code type safety. If your solution looked similar, super awesome, you've done a great job. If it does look cooler, then you've done an even greater job. Now, just know that, again, I have made the items private because nobody should be able to just get the items out of there. You use these methods or functions to manipulate the items array without the world around it being able to access it and fuck up your array. We have used generics here to create a queue that can be used for any type of item. There's no extents here, so there's no limitations on what it should be able, to get in. And that's basically how generics work. So today we explored the power of generics in TypeScript and learned how they help us write reusable type-safe code. From generic functions to classes, generics are an essential tool for modern TypeScript development. In our next episode, we'll bring all of this together, everything that we've learned so far, to create a mini project in TypeScript. It's just a TypeScript project, no HTML, just a small application. Thank you for watching. Be sure to click the bell button and the subscribe button, and I'll see you next time. Have a great day and happy coding.